All right, welcome to the online soils lab. Hopefully you watched the first video going through the PowerPoint slides, and now this is a video on what you would have actually done in class if you had been here. So have your lab report open so that you can fill out the numbers as we go through them. And so we're going to start with part one. Let me get my step-by-step sheet here. So we're going to start with part one on the bulk density and soil tilth. I have all of the equipment set out here. It's off screen. And so we're going to start with first weighing a dry crucible and recording its measurement on our data sheet. So the weight of the crucible is 26.87 grams. And we'll use the same crucible through the whole thing. So for all of them, it's 26.87. All right, so now we're going to start with our coarse textured soil. And our coarse textured soil we're going to use is this Macloam loam. So it is a loamy soil, but it has a lot more sand in it than a lot of the other particles. So it's more of like a sandy loam. And that's going to be our coarse textured soil. So I'm going to add it slowly until the crucible level is full. I have my handy scoopula here. Spilled a little bit. All right, compact the soil by gently tapping the crucible on the desk, and then refill until level and strike off. Okay, so here's our full crucible with soil for a coarse textured. So the weight of the crucible in soil is 100.76 grams. You get to determine the weight of the soil by just taking that last measurement and minusing the weight of the crucible. So I will leave that to you. The next step is to transfer the soil from the crucible into a mortar. And then we're going to add an additional 1/2 crucible just because we are going to pulverize this. And then refill it into the crucible to represent an over-tilled soil. So if you think about tilling practices done, all right, they're meant to break up large clumps of soil, but it also makes it very easy to compact the soil then. Not too many rocks in this. If you are interested, both of the soils we are using today in lab came from my grandpa's farm in Michigan. So both of these are used to grow plants in crops. This one right here, I believe he uses to grow corn. And then the other one we're going to talk about, he uses to grow wheat and alfalfa. All right, so this is pretty pulverized. I've gotten rid of all the big clumps. So we're going to refill the crucible and compact it again as described in step 2. Okay. All right, so our second full crucible, this time with compacted soil. Let me put some more in there. The trick is to always tap down with the same amount of pressure each time. I don't always do that. All right. There's a little bit of plant residue in that. All right, so this now weighs 123.14 grams. And again, you can figure out the weight of the compacted soil. And then we're going to place this pulverized compacted sample on a piece of wax paper and save it for the next part. I need to grab my wax paper. So all right. So I'm done with this coarse soil. So I'm going to put the leftovers back in the bag. Move my desk a little bit. And we're going to move on to the the fine textured soil. Fine textured soil. So this happens to be Brookston loam that has a little bit more clay and silt in it. So we're going to do the same thing. We're using the same crucible. So I'm going to fill it until it is level. Tap it. All right. So the weight of the fine textured before compaction is 107.84 grams. Now I'm going to do the same steps where I add it to my mortar. Along with another half crucible level, and start pulverizing. All right. I think that's pretty good. Not all of the aggregates are broken up, but they're at least smaller than they were before. So kind of a nice powder. I'm going to refill the crucible. And now compact it in. Right, and this one is 134.01 grams. Then put that on a piece of wax paper. Back. All right. So now to finish off part one, we need to determine the volume of the crucible. And we do that by adding water to it, because we can assume that 1 gram of water equals 1 millimeter of water, and that equals 1 cubic centimeter of water. So put my crucible back on the scale, and now as you can see in the lab report, we are going to determine the volume of the crucible by filling it full with water. And then we're going to use the wash bottle to add in a few drops to get it up to the top. And we can confirm our statement by pouring the water from the crucible into a graduated cylinder and double checking that. All right, so I'm pouring. So we can get up close to the lip of the crucible, but just to be careful to not go over. That's when I'm going to start using the wash bottle. And knowing that with the soil, I really went all the way up to the top. That looks pretty good to me. So you can kind of see the reflection of the water on the crucible. That's how we do that. So the weight of the crucible in water is 89.28. So that's going to be the same across that table. I don't know how good I'll be about not spilling any of this water, but again, you could double check your work, and I did spill some of it. But to get the weight of the water, all right, then you just take that measurement and minus the weight of the crucible from it. And it's the same across the table, so I'm going to fill that in. And we do get pretty close. So I'll leave you to figure that out, that equation yourself. You can maybe barely see that, but we were pretty close. And I dumped some water out on the table, but on accident. All right, so you can figure out the weight of the water then just by doing the weight of crucible and water, minusing out the weight of crucible. And then you can determine the volume of water because it's literally the same number, but we are doing 1 gram of water equals 1 cubic centimeter of water. So our units are just changing. I'm just filling in my table, making sure I didn't miss anything. All right, so you should be able to now figure out the bulk density for these soils, and the equation is right there for you to use. All right, weight of the dry soil divided by the volume occupied in cubic centimeters. So that's the end of part 1. Part 2 for bulk density is taking those samples I set aside on wax paper and bringing them to good tilth. So if you look through the lab report, because there's sections on important terms to know. So we want to bring it to what we call field moisture capacity, which is the amount of water soil can hold following like a rain event, and then a 2 to 3 day drainage period. So it's basically filling up those pores with water, but not too many of the air pores. And we want to bring it to good tilth, which is the physical condition of the soil in relation to its ease of tillage, capacity to germinate seed, and support plant growth. So I'm going to start with our coarse soil. That had been compacted, still staying in the shape of the crucible. And we add water, but not too much water. And the soil is pretty dry, so it's not the easiest to add more water to this. So I'll be able to show you a little bit, but then I'm going to have to use my hands to mix it. Although this is a coarse textured soil, which means it's sand, makes it a little bit easier for it to take up the water than our fine textured. Still have to mix it around. So that is what I'm doing, even though you can't really see it, using my fingers. And stuff all over the place. All right, so you'll see with water that it does come back up again, but I don't have too much moisture, so that like if you squeezed it, no drops of water come out. So I would say that this is pretty good tilth. So now we're going to fill the crucible full of this good tilth soil. Compact it again, as we did back in step 2. So let me oops. All right. All right. So we're using the same crucible as we did in part 1, so it still weighs the same. But now we need to know the weight of the crucible and soil that's been moistened to good tilth. So for the coarse soil, that is 112.17. So then you can figure out the weight of the soil moistened. We are going to oven dry this. So we need to place it into something that can withstand 106 degrees Celsius, which is just these little paper cups. So I'm going to label this one as coarse soil. And weigh it. So the weight of our paper cup is 1.65 grams. And then I transfer this over to the paper cup so that it can go into the oven. All right, there's our cup. It's going to go into the oven. Do the same thing for our fine soil. This one's going to take a lot more water. Tiniest bit more water. There. Hopefully get the rest of this. Mix it in. So again, because this is very clay and silt, really wants to stick together and stick to my fingers. That is our good tilth soil, moistened. So we're going to put it into our crucible. And this is 124.37. The paper cup we're going to be using for this is 1.63 grams. All right, on it fine soil. And transfer that over. Just doesn't like to transfer over. All right. That's that cup. All right. So, you should have been able to fill out your sheet as I went along and did these. And you can, the areas where I have blanks, you should be able to calculate those answers. The only thing you can't turn in right now is this shaded part, because this is where the weight of the oven-dried soil starts. And then being able to calculate water loss and percent water in sample, you need to know the oven-dried weight. I'm hoping to get those up onto Moodle by Friday, or the end of Friday, because it's just 2 numbers. So I'll be able to just post that on Moodle. You can put them into this table and do the rest of the calculations. On the back side of that page, this is giving you some information like weight of the soil at field capacity, and then the weight of the oven-dried soil. And then again, using the equations you know to figure out bulk density, you are going to have to determine the volume of the core, which we're saying are these metal cores here, and that equation to figure out the volume is right there. And then you can figure out bulk density, you can figure out water holding capacity, the equation's there, and you can think about the bulk density number and how that might relate to any issues plants would have growing in the soil. Part 2 is on pore space. And so there's nothing really hands-on to do with the pore space and internal surface. It's mostly reading through this and then figuring out the equations. Also, you need to use your data from the first part here. So you'll see, to figure out percent pore space, you need to know bulk density and also your specific gravity, which is particle density. So once you figure out your bulk density of your dry loose soil, your dry compacted soil, and then your good tilth soil, you'll be able to plug that into the equation. Assumes that the particle density is 2.65. Like I said, we do in the PowerPoint. You know, if you're not going to specifically measure particle density, we can assume it's 2.65, and that will help you fill out this part. Question 2 is using the equation for internal surface area, which is right here. Plugging in those numbers to fill that out. And then question 3 is calculating the pore space of these following samples with a given soil texture, bulk density, particle density, and you use these equations down here to fill in the rest of the table. The back of the pore space and surface area just has some short answer questions to fill in to consider, you know, the differences between surface area of sand versus clay, what's good for plants, what effect it might have as far as water holding capacity, you know, what does organic matter do? So those are just some thought questions to get you thinking about everything we've talked about. So whether you use the Word document or the PDF, but you should be able to fill in those boxes, write your short answer questions, and submit that back on Moodle under the Dropbox, and it's due next week, Tuesday, by the end of the day. And like I said in the first video, we will be putting up a review for next week because that is our midterm exam in lab. You'll still go to your normal lab, and it will be a paper exam for you to take there. So I do believe that's it. Now I just have cleanup. I'll show you guys the oven too. But now I just have all this cleanup to do. But I will take care of that. Here are our ovens. They're pretty simple. Nothing in that one. So you turn it on. And then you turn the dial to set it to a temperature, degrees Celsius. Remember, we want it at 106. So I'm going to see where that gets me on the dial. Open this up. Put my 1 cup in there. Put my 2nd cup in there. There they are. Okay, so if you have any questions, you can reach out to me or your lab instructor. But otherwise, have fun doing this online, and we'll see you in person next week for the midterm.